Hello, my name is Curtis Schneiders. I want to show you my most recent project. It's a Lego dart shooter, but of course it's a little bit more complicated than that. So first things first, it has the ability to point the shooter left and right, called traverse, and angle the shooter up and down, called elevation. This is a continuation of my last video that I made in January 2024. If you want a little bit more context, I suggest you watch that one too. The idea is that the shooter is placed in a 3D space, given an object's x, y, and z coordinates. It will calculate the angle of the shooter needed to traverse to face the object and elevate the shooter in order to hit the target. When shot, the dart should hit the target. The z coordinate is relative to the robot. So if the object is above the robot, then the z coordinate is positive. If it's below the object, then the z coordinate is negative. I mentioned before that this is a sequel to my upload in January. Now the robot has more capability and the user experience is much smoother. The shooter can now shoot at targets above and below it instead of just above it from a previous version. I wrote the program entirely in the Mindstorms Robot Inventor app, which it's basically just the way you can program, or how you can tell this little computer to tell the motors to run, basically. It's a microcontroller, like an Arduino or a Raspberry Pi, kind of. I learned a bit of Python so I could create the functions. With my last shooter, I used a C++ program, which is a different programming language, to calculate the elevation angle, and a Scratch program to instruct the robot what to do. With only one program, the Python program, all the user has to do is input the shooter's velocity and the target's x, y, and z coordinates into the Python program. It will calculate the precise angle needed to hit the target and send the instructions to the robot so it can traverse and elevate the shooter. The program will tell the user if the target is out of reach or if in reach, and gives the user the maximum range given the velocity and z value of the object with its corresponding angle of elevation. To calculate the angle needed to hit a target, the robot uses formulas I derived using kinematic equations I learned in physics class. Basically, they are equations of a moving object through space and subject to a planet's gravity. I will make another video specifically explaining how both formulas were derived. If you look at the formulas, they both solve for a range given an angle, initial velocity, and some vertical height. I don't know about you, but solving these equations for theta, or the angle, it's pretty much impossible. Instead of solving for a specific angle, the program calculates the range of all angles from 90 degrees down to 0 degrees to find the exact right angle needed to hit the target. I specifically chose sweeping from 90 degrees down to 0 degrees so that the dart has a steeper angle on the way down. That way, any error from the motor, encoder, or calculation is less obvious. Okay, so that's my video. I really hope you enjoyed it. I enjoyed making it. I enjoyed the process of coding and creating the physics equations and different stuff like that. As for maybe part 3 of this little series, I'm working on trying to develop an encoder, which basically it tracks how much the shooter rotates. So instead of the way this works now is this basically starts at 0 degrees, so then it'll calculate the angle it needs to traverse to hit the target, and then it'll rotate back to 0 degrees, and then it has to be calibrated every time. So I want to add an encoder in this, which it tracks what angle the traverse is at any given time. So hopefully I could do something like, hit a moving object or track a moving object, a little bit more complicated. I was thinking about using parametric equations, so x of t, y of t, z of t, just to track a moving object through 3-dimensional space. I feel like that would be fun. I don't know how easy it is to implement into a program, but I'll figure that one out. Or I won't, and I won't make another video, but I don't know, whatever. See ya. Thanks for watching the video.